All right, so this is our second lesson on vector addition, or working with vectors, excuse me. So when vectors are written in component form, they can be easily added, subtracted, or multiplied by a scalar. Notice it's multiplied by a scalar, not by each other. We'll get into that in a later lesson. So for vector addition, if you have two parts, your horizontal and vertical, horizontal, vertical, they can be, and k is a scalar, so all we have to do to find the sum, or to take a plus b, we're going to get the two first ones and the two second ones added together. So in other words, everybody in class figured this out really quick. You add these two and get 19, and then you add these two and you get 21. Okay, there's your two parts. All right, so when we go to multiply, notice we have k as a scalar. So here it is here, and we don't call it a coefficient, but it's very similar. Here's your k, and it distributes all the way through. Okay, and guess what else can distribute? This negative distributes over here. Okay, and these are nice little representations of, here's the length of v, and if you double the v, it's here, and half the v is there, negative v is there, and notice the arrow changed and went the other way on that one. All right, so here we go with multiplying. Here's your scalar, so you multiply both pieces, and we get 8, negative 6, and distribute the negative, you get 5, negative 2. All right, very simple. So I had the kids work these problems. In fact, I think I may have left one out. All right, I don't think so. All right, so a couple of ways to do this. Technically, what you're supposed to do for this is you get negative 3, 5, and we distribute and get negative 4, negative 8. And then you add your horizontal component, which is negative 7, and then vertical component, negative 3. All right, I'm going to show you another way. I'm going to change the signs of what I have so you can see that. I'm a little far off. I'm going to zoom in just a little bit. Okay, that makes it a little bit bigger. All right, so this is going to give me 9 and negative 11. All right, so all the kids work these. I did one of them, and I let them fill in the other ones, but I'm going to go through, work them real quick. If you want to pause this and see if you can get it, you're more than welcome to. So 5, negative 7, minus 0, 4. All right, so that's going to give us 5, distributing 5, negative 11. All right, and then on this one you have 3 times, and this should be component form, 5, negative 7 plus p, negative 1, 3. All right, first distribute, that's 15, negative 21, and then plus 1, or minus 1, excuse me, 14, and plus 3, negative 18. There you go. And then 7 times p, well, p is negative 1, 3, and then multiplying through, negative 7, 21. And then over here, 2 times m, 5, negative 7, plus 2 times n, 0, 4, minus p, negative 1, 3. Distribute that negative, plus, plus, minus. This is just, we've got to distribute first before adding, just like we do in algebra. I told you this was a piece of algebra. All right, and then plus 0, 8, and then plus 1 minus 3. All right, so collect, I'm going to do this, underline it in pink. That's going to give us 11. And then all the other ones, that's -6, and -3 is -9. Okay, good. Got it all done. So if you paused, you can flip it back on and check it. Let me give you the other part of the notes. All right, so on this page, okay, so a vector that has magnitude of 1 unit. So a vector, if we have a magnitude of 1 unit, and we had a unit circle that had a radius of 1 unit, and we called it the unit circle, guess what you call a vector with 1 unit? A unit vector. Unit vector. Okay, and it's represented by the x, or the x-axis is directed by I, the y is by j. All right, and so here we have, this is what the vectors I and j look like. This is component form. And this is unit vector form. All right, and so looking at this, how do you rewrite these? Well, 4i plus 8j. This one's -7i plus j. This one, we want to write this in component form since it's already in unit vector form. 5, -6, -2, -9, and we're done. And the guided practice, I'll do that real quick because the rest is for you to do for homework, and this is pretty easy. So 2u, I had somebody tell me, now what you're supposed to do for this is this, but I'm going to show you what one of the kids did, which I thought, hey, I'm really proud of you. You're thinking. That's awesome. So -2i plus 8j. Wow, did I ever not give you enough room for this? So this gives you 10i minus 6j minus 2i plus 8j. Tired of writing in pink. Let's go to green. Collecting my i's, I'm at 8i and -2j. And let's get enough room to do number 2. Somebody told me, they said, Miss Butel, I changed these to component form. Is that okay? The answer is sure, but if the answers are given to you in vector, unit vector form, then it needs to end there. So if you did this and you said 5 -3 minus 3 times -2, 8, then that would give you, the 5, 3 wouldn't change, but multiplying through the negative would become plus 6 -24. Okay, look how much shorter of a space that is. That's really nice. And considering the room that I gave you, that's probably a really good idea. Okay, so this gives you 11 -27. This one, oh, and I can't leave it like that. I have to say 11i minus 27j. And -3u, u is 5 -3. So it's -15, positive 9. So that's -15i plus 9j. And 5u plus 2u, 2v, excuse me. 5i minus 3j. Ah, dang. I mixed the 2 up. -2, 8. This should have just been 5 -3. I'm crazy, but oh well. All right, so that gives me 25 -15 plus 4, wait a minute, -4 and 16. All right, so finishing these out, I get 21 and 1. So I would write 21i plus j. Somebody did, well, look at there, I got off the page. Somebody did ask me what happens when you have a 0. Well, just like if you had 0x, you would leave it out, okay? I did double check on that to make sure I was right. So Hey, you guys have a great spring break. Get your homework done. Make sure you're finished on this. All my other classes were able to do it, so have a good one.